Now we want to solve some more problems from our exercise. Here to solve that problems, you should remember the following relations or equations from second law. We got the equation F is equal to M into V minus U by T, or F is equal to M A, and from third law, action equal to minus reaction, and then conservation of momentum, M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2, and also momentum P is equal to MV. These are the equations we require for solving the problems given. Among that, first one from our exercise, today we are going to discuss question number 9. What is the momentum of an object of mass m moving with a velocity v? You want to find out what is the momentum of an object moving with a velocity v. You know, momentum is the product of mass and velocity. So here the relation given mv. The answer is D. Answer is D. Momentum P is equal to mv. That from that we getting this relation. Now question number 10. Using a horizontal force of 200 Newton. Using a horizontal force of 200 Newton. We intend to move an wooden cabinet across a floor at a constant velocity. What is the friction force that will be exerted on the cabinet? Once again, using a horizontal force of 200 Newton, we intend to move a wooden cabinet across a floor at a constant velocity. What is the friction force that will be exerted on the cabinet? Here you see the cabinet is moving with a constant velocity. It is moving with a constant velocity. So that does not produce any acceleration. Hence, force F is equal to, we know, ma. From this relation here, it is moving with a constant velocity. Constant velocity, hence acceleration is 0. Acceleration is 0 means net unbalanced force. This A is 0. Hence the net unbalanced force is 0. Hence the force applied 200 Newton is equal to frictional force. The applied force 200 now becomes equal to what is frictional force. So here the frictional force is how much? 200 Newton. Frictional force is 200 Newton. Now question number 11. See, two objects each of mass 1.5 kg. Two objects of mass 1.5 kg are moving in the same straight line but in opposite direction. Let the first one, mass m1 equal to 1.5 kg, and second one, mass m2, that is equal to 1.5 kg. They are moving in the same straight line but in opposite direction. the velocity of each object is 2.5 meter per second. That means velocity, first one we can take as u1 is equal to 2.5 meter per second. And also second one u2 is equal to the same velocity 2.5 meter per second. What will be the velocity of the combined object after collision? See, after these two collide, what will be their velocity? They are moving together. Let this first object is moving from left to right. Then its velocity u1 is positive. And second object from opposite direction is from right to left, that will be then negative. So the velocity of the second one, that is u2 is negative. Now first of all we can find out momentum before collision, then momentum after collision. But we know by law of conservation, momentum before collision is equal to momentum after collision. That is momentum before collision is equal to momentum after collision. Momentum before collision, that is m1 u1 plus m2 u2, that is equal to momentum after collision. That two are moving together. So mass m1 plus m2, that means they are moving together with a common velocity. So that we can take as v. Now m1 u1, m1 is 1.5 into velocity 2.5 plus m2, that is 1.5 into velocity minus 2.5, that is equal to 1.5 plus 1.5 into v. But you see 1.5 into 2.5 plus into this, these two are the same quantity, but here on negative. So by the product of this one and the product of this one, when taking, we get together them as 0. So here 3v is equal to 0. Here adding 1.5 and 1.5, we get 3, and into v, we get 3v is equal to 0, or v is equal to 0. That means after collision they are not moving. After collision they are not moving. This we conclude from this observation. Okay. Now I hope you got idea about how to solve this one. Now we can go to the next one. Question number 12. According to the third law of motion, when we push an object, the object pushes back all as with an equal and opposite force. If the object is a massive truck parked along the roadside, it will probably not move. A student justified this by answering that the two opposite and equal force cancel each other. Comment on this logic and explain why the truck does not move. See, we know action and reaction are equal and also opposite. But they are not acting on the same body. Action and reaction equal and opposite, but they are not acting on the same body. Hence, they are not cancel each other. They will not cancel each other. is not moving because the force applied by the student is not sufficient to overcome the frictional force between the tire and the rod. That means the force applied is not sufficient to overcome the friction, hence the truck is not moving. Why the truck is not moving? What is its answer? The force applied is not sufficient to overcome the friction, so the truck is not moving, and not because of that action and reaction cancelling. And question number third one, that is 13th one. Now the 12th answer you got action and reaction not cancel because here truck is not moving. The reason is that the force applied is not sufficient to overcome the friction. Now 13th question, a hockey ball of mass 200 gram. A hockey ball of mass 200 gram, that we can change to kilogram, that is by dividing with 1000 we get 0.2. A hockey ball of mass 200 gram traveling at 10 meter per second, and it is traveling at a speed of 10 meter per second. Struck a hockey ball of mass 200 grams traveling at 10 meter per second is struck by a hockey stick so as to return it along its original path with a velocity of 5 meter per second, and it returns. Suppose this one is going with a velocity v1 and returning with a velocity v2 at a speed of how much? 5 meter per second. See, here is the first hockey ball is moving with a 10 meter per second, and by hitting with a hockey bat, this one is returning to this direction. Now the direction is changes, so this one is minus 5 meter per second. So V2 is a minus 5 meter per second. Okay. Now calculate the change of momentum occurred in the motion of the hockey ball by the force applied by the hockey stick. That means the hockey stick applying a force, and we want to find out the change of momentum. Okay, we know what is the change of momentum is equal to change of momentum. How we get a change of momentum? What we want to find out? We want to find out change of momentum. See, change of momentum is equal to final momentum minus initial momentum. Final momentum minus initial momentum, that is final momentum is m mass common, so m into v2 minus m into v1, that means we can take as common v2 minus v1, so that is equal to m into m. How much is the mass? 0.2 into v2. V2 is how much? Minus 5. Minus 5 minus v1. v1 is how much? 10. That is equal to 0.2 into minus 5 minus 10, that is minus 15. That is equal to 2 into 15, that is equal to 30. Here on decimal points that we are given, that is equal to minus 3 kilogram meter per second. This is the change of momentum. Here negative side coming because the ball is moving now in the opposite direction. So change of momentum is how much? Minus 3 kilogram meter per second how we got it? We subtracted initial momentum from the final momentum. Now question number 41. A bullet of mass 10 gram traveling horizontally with a velocity of 150 meter per second. A bullet of mass of bullet, let it be M1, is equal to 10 gram. Mass of bullet 10 gram. And it is moving with a velocity of velocity v1 is equal to 150 meter per second, and strikes a stationary wooden block and comes to rest in 0.03 second. It hit a wooden block and after 0.03 second it comes to rest, and t is equal to how much? That is equal to 0.03 second. Calculate the change of momentum occurred in the motion of the hockey. Calculate the distance of penetration of the bullet into the block. Also calculate the magnitude of force exerted by the wooden block on the bullet. Two things we want to calculate. First of all, calculate the magnitude of force exerted by the wooden block and also calculate the distance of penetration of the bullet into the block. That we want to find out, yes, distance of penetration. Then force exerted. These two things we want to find out. See here, mass is given. That is 10 gram. To change this gram into kilogram, what we want to do? We want to divide with 1000. Then this will come 0.01 kg. 0.01 kg. The bullet is finally comes to rest. So that velocity, final velocity. First we took velocity of the bullet is 150 meter per second. Here it is better to take instead of v1 we can take as u, initial velocity, and final velocity v is equal to we can take as 0. Initial velocity u is equal to 150 meter per second and final velocity v is equal to 0 because the bullet comes to rest. Now what are the things we know? V, u and also t. We can find out acceleration from this set. So first of all we know v is equal to u plus at. Here v final velocity is 0, initial velocity is 150 plus a acceleration we don't know into t 0.03. From this quantity, from this relation we can bring this two to this side. Then a into 0.03, that is minus is equal to here 150. Now this minus 0.03 we can shift it to that side. Then a is equal to this minus when come to here we can write it up 150 divided by 0.03. Now here 2 decimal. Here 2 decimal. So to remove this decimal, first of all what we can do? This we can multiply with 100. Then how this become? Minus 150 into 100 divided by 3. This 150 and 3 we can cancel. How many times? In 15, 5 and 0. That means here how much? 150, that is 50 into 100, that is a is equal to how much will come? A is equal to 5000 minus 5000 meter per second square. Meter per second square. This is the acceleration. This is the acceleration. A is equal to how much? Minus 5000 meter per second square. Now we got acceleration. So from this relation, that means from this value we can find out distance. That is v square is equal to u square plus 2as. Or we also know the relation, another relation, what is 2as equal to v square minus u square. From this 2 into a, how much? Minus 5000 is equal to v square is 0 square minus u is 150 square. Now here on s also to find the s. That is 2 into 2. A is this one, s is there. Okay, 2a and s. v is equal to 0 square and u is 150 square. Now to calculate s is equal to 150 square. That is minus 150 into 150 divided by. This minus is not for this 150, it is common for this 2. So that is again by minus 2 into how much? 5000. Now we can cancel 110 again 1. Then we know 15 into 15, 225, 2 into 50, 100. That means this will come minus by minus become plus. 15 into 15, 225 divided by 2 into 15 is equal to 100. 2 into 50 is equal to 100. 225 divided by 100, how much will come? That is equal to 2.25 meter. How much it will be? 225 by 100 is equal to 2.25 meter. 2.25 meter. This is the distance of penetration. Of the bullet in the wooden block. Okay. Next, one more thing we want to find out. What is the force exerted by the wooden block on the bullet? Force exerted by wooden block on the bullet. We know the relation from second law, F is equal to ma. That is m is equal to how much? 0.01 into a, this 5000 minus 5000. That means when we multiply this 5000 with 1, there is no change. The same value will come, but there is 2 decimal point. So we want to remove 2 decimal by shifting this. This one multiply, we get 5000 with the negative sign. See, 1 into 5000 is 5000 itself. But here 2 decimal, so here we can give it. Now that is equal to minus 50 Newton. Minus 50 Newton. This is the force exerted by the wooden block on the bullet. How much is it? Minus 50 Newton. Why this minus is coming? Because this force is opposite to the direction of motion of the bullet. If the question is that how much is the force exerted by the wooden block, means it is 50 Newton. But this negative sign shows that this force is opposite to the direction of motion. Okay. Now see next question number 51. An object of mass 1 kg traveling traveling in a straight line with a velocity of 10 meter per second collide with and sticks to a stationary wooden block of mass 5 kg. Then they both move off together in the same straight line. Calculate the total momentum just before the impact and just after the impact. Also calculate velocity of the combined object. See, an object of mass 1 kg. So m is equal to 1 kg. Traveling in a straight line with a velocity of 10 meter per second. See, it is moving with a velocity v is equal to 10 meter per second. Collides with and sticks to a stationary wooden block of mass 5 kg. Suppose this mass we can take as M2. It is 5 kg. So here the mass we can take as M1 and this velocity we can take as V1. And what we want to find out, then the both move off together in the same straight line. Calculate the total momentum just before the impact and just after the impact. Also calculate the total velocity of the combined object. Let V be the velocity of the combined object. Okay. Now we know before collision the mass of this first one M1 is equal to 1 kg and its velocity is this one. And mass of M2 second one is 5 kg and its velocity, let it be V2 is equal to that we can take as 0 because it is at rest 0 meter per second. Before collision momentum is equal to momentum is equal to M1 V1 plus M2 V2, that is equal to momentum before collision is equal to M1 V1 plus M2 V2, that is equal to M1 V1, M1 is how much? That is 1 into V1 is 10 plus M2 is 5 into 0, that is equal to 1 into this 1 into 10, that is equal to 10 and 5 into 0 is 5, that is equal to 10 kilogram meter per second. Now then after collision momentum, after collision we know what is the momentum before collision is equal to momentum after collision. So momentum after collision is equal to is equal to 10 kilogram meter per second itself. Momentum after collision, because momentum before collision and momentum after collision they remains the same. Now what we want to find more? We want to find the velocity of the combined object. See, momentum before and after collision same. So after collision, that means M1 plus M2 stick together and its velocity v, that is the momentum of these two, and it is equal to momentum after collision 10 kilogram meter per second. From this M1 and M2, M1 is 1 plus M2 is 5 into v is equal to 10. So 6v is equal to 10 or v is equal to 10 by 6, that is equal to 1.66 this meter per, that is approximately 1.67 meter per second. This is the velocity of the combined object after collision. That is how much it will be? It will be 1.67 meter per second. Okay. Now what are the things we find out? Momentum before collision, momentum after collision, then velocity of the combined body. Okay, these three things. I hope you got idea about this. Now we can go to next problem. 16th one, an object of mass 1000 kg is accelerated uniformly from a velocity of 5 meter per second to 8 meter per second in 6 seconds. Calculate the initial and the final moment of the object. Also find magnitude of the force exerted on the object. An object of mass 100 kg. Let mass be here we can take as m is equal to 100 kg. Okay. Accelerated uniformly from a velocity 5 meter per second. That means at the first velocity u1 is equal to 5 meter per second to that's velocity changes to 8 meter per. Then let u2 is equal to 8 meter per second. Meter per second. Velocity u1 changes to u2. And the time taken for it t is equal to 6 seconds. Time taken for this change is 6 seconds. Calculate initial and final momentum of the object. Also find the magnitude of force exerted on the object. See, initial momentum, we know initial momentum is equal to mass m into u1. That is mass into velocity 100 into 5. That is equal to 500 kilogram meter per second. 500 kilogram meter per second is the initial momentum. Then its final momentum. Final momentum is equal to mass into final momentum is mass into final velocity. That is mass is 100 into final velocity h. That is equal to 800 kilogram meter per second. Now we got initial momentum and final momentum. Now we want to find out change. That means a force exerted. Force means rate of change of momentum. That means force equal to what is actually force? Change in momentum by time. Then we get what is rate of change of momentum. Force is the rate of change of momentum. Force is the rate of change of momentum. That is m1 m into u2 minus u1 by t. That is m into u2 minus u1 by t. Or otherwise we can find out this 100 minus 500 divided by time. From that also we get it. So that is 100 into 8 minus 5 divided by time taken is 6. That is equal to 100 into 8 minus 5 is how much? That is equal to 3 by 6. This we can divide. How much it will come? 2. 100 by 2 is equal to how much? 50 Newton. Once again, here also we can get it from final moment 800 minus 5 300. 300 by this 6 seconds. That also get it 50 Newton. Or force equal to final momentum minus initial momentum. Final momentum m into u2 minus initial momentum m into u1. M is common, so m into u2 minus u1. From this also we can find out force or rate of change of momentum. Now question number 17 one. Akhtar, Kiran and Rahul were riding in a motor that was moving with a high velocity on an expressway when an insect hit the windshield and got stuck to the windscreen. Akhtar and Kiran started pondering over the situation. Kiran suggested that the insect suffered a greater change in momentum as compared to the change in momentum of the motor car, because the change in velocity of the insect was much more than that of the motor car. Akhtar said that since the motor car was moving with a large velocity, it exerted a large force on the insect, and as a result, the insect died. Rahul, while putting an entirely new explanation, said that both the motor car and the insect experienced same force and a change in their momentum. Comment on these suggestions. Here Rahul is correct because see force exerted by each of them remains same by Newton's law, action and reaction equal and opposite, and also force exerted experience the same force and change in their momentum. Change in their momentum, we know what is the rate of change of momentum because they are also same. So Rahul is correct because force and rate of change of momentum remains the same. Now we can go to question number 18 to 1. How much momentum will a dumbbell of mass 10 kg transfer on the floor if it falls from a height of 80 cm? Take its downward acceleration is 10 meter per second square. See, M is given as 10 kg. M is given as 10 kg and height S is given as 80 cm, that is equal to 0.8 meter, and acceleration is equal to 10 meter per second square. We can find out, take it downward acceleration. How much momentum will dumbbell of mass 10 kg transfer to the floor? We want to find out how much momentum that dumbbell exert on the earth. See, here it's a final velocity. Initially it was at rest, so u is equal to 0. Now we want to find out the final velocity. V is equal to how much? V is equal to, we know, here is some relation. V square is equal to u square plus 2as. The same relation that is third equation of motion. Third equation of motion we get it. V square is equal to u square plus 2as. Here V square is equal to u is 0 plus 2 into a 10 into s. That is how much? 80. That is 0.80. Now V square is equal to this 0 we can leave. Now 2 into 8 is 16 into this 10 0. Now here is on decimal. 2 into 8 is 16 and multiply with this 10 on 0. Now put a decimal. That is equal to 16. So V is equal to root of 16. That is equal to 4 meter per second. So the momentum of the dumbbell when it hits on the floor, we know what is momentum. V is equal to mass into velocity. Momentum is equal to mass into velocity. So that is equal to m. M is how much? M is 10. And V is how much? 4. That is equal to 10 into 4. 10 into 4 is how much? That is equal to 40 kilogram meter per second. 40 kilogram meter per second. So these are the problems given in your exercise to solve these problems, what are the things you want to remember? You should remember about this equation. That is from second law, rate of change of momentum. That is equal to m into v minus u by t, and also f is equal to mk. Then sometimes you want to use the relation Newton's third law, action equal to reaction, but put a negative sign. For why we put a negative sign? Because they are acting in the opposite direction. They are acting in the opposite direction. Then law of conservation of momentum. What is law of conservation of momentum? Says initial momentum before collision. That is collision before collision. Momentum adding. That is equal to collision after. Momentum adding. That two are equal. Momentum before collision is equal to momentum after collision. Then the relation connecting momentum P is equal to m into v. Then some equations of motion also you want to remember here. One is v is equal to u plus at, and second one s equal to ut plus half at square, and third one is equal to this relation v square is equal to u square plus 2as. Okay.